my TTL computer, starting on the next revision, I've decided to take this particular hardware further. And kind of the reason for that is that the memory chip, the RAM chip I have in here is actually 2K, 2000 byte RAM chip, even though the computer hardware as it stands can only use 16 as designed. So it's only using 16 out of 2000. So I decided that I'm going to take this further so I can on a path to use that full 2K of memory and expand the hardware significantly for more functionality that I'll describe as we go along. But actually, so this looks like it's running the same. It's running the up-down program again, counting up to 64, and then back down to 0 and continuing. So it looks like it's doing the same old thing, but actually a lot of changes have occurred in the firmware, mostly in the firmware really. So right now this is running at almost 20 times faster than it was before. So the clock frequency was about 15 hertz before. Now it's up to 250 hertz. And that really was the first step in the next revision of the expanded implementation of the hardware, because I'm going to need a much faster clock cycle to accomplish what I plan to do, and that is to basically add terminal capability, and it's going to need a much faster clock speed to do that. So increasing the clock speed broke the computer again. As I mentioned, this up-down program had tended to show glitches when they occurred in the system, and it did that again. And besides updating the clock speed to 250 hertz, I also had to pull out those two problematic chips and update and redo the firmware. And that was the control unit and the ALU, the arithmetic and logic unit, where I said that was sloppy. I had to redo the code on both of those, and they're pretty well organized now, and especially the ALU. But I think that those are pretty stable now. And then the up-down program was still, even with that updated firmware in both the control and the ALU, running this up-down program, it still glitched out. And it looked like the ALU was at fault, where it was just going into a dumb state. It wasn't releasing the bus and wasn't accepting any control signals. And that was after I redid all that firmware. So I just thought it could possibly just be a power problem, on the stupid breadboard here, which is, known to be not overly stable. And these are these Chinese ones again, where it's just problematic connections. So I added a secondary path for power on the ALU, so it's getting power from two separate power rails, and programmed it up, and it's running now, and it's looking good. So I could possibly have done all that firmware where it wasn't necessary, and it was just this power problem all along. Likely not. As I said, the firmware on the control unit and the ALU are in pretty good shape right now. They're pretty much where I would have them be, and that with the additional power source going to the ALU, things are running pretty good now. So this is really the foundation for all of the coming changes in this next revision. It's going to be substantial changes, and I'm going to take them on. That will be done incrementally. So the first goal is going to be getting to to an 8-bit address. Right now we're using a 4-bit address for the memory, I'm going to move that to be an 8-bit address, and that will, but just to get there, that means we're going to be moving to a 2-byte instruction word. Right now it's a 1-byte instruction word, and the single byte contains both the opcode and the data. So we're going to split that into 2. So it'll be 1 byte for the instruction and an optional 1 byte for data. So to achieve that, first we're also going to have to update the control unit to go to an 8-step instruction cycle. Right now it's only a 4-step instruction cycle, and this is our step counter over here, which just looks solid right now. But we're going to have to change that from, I said, from 4 to 8. So that's going to require code changes in the ALU to achieve that. So I'm going to make those changes first, get that working on the current hardware, the 1-byte instruction. Then once that's done, because we'll need that to go to the 2-byte, then we'll implement the I'll implement a 2-byte instruction, all still on the same, only on a 4-bit address, using the 4-bit address bus. Once the 2-byte instruction code is working, then we'll start working on the, we'll have to update the program counter. Now the program counter is here. We're going to have to update that from a 4-bit counter to an 8-bit counter. Then once that's done, then we will move all of the memory access to be an 8-bit memory address, and then that will be the hardware changes that we need for the foundation. Then after that I will start working on the serial I/O interface. So want to be able to get a terminal to work with that. So we're going to need to have a serial in and a serial out capability added to the computer. And once that's all done, then I'm actually going to try to do a little bootloader where I can then program the computer via the serial bus from a remote terminal. So that's the rough game plan in a nutshell. Quite a lot of steps. We're going to do it, incrementally, make sure nothing breaks along the way. But it's going to be a bit of a journey to get there. Probably it's going to be as much work as what we've done so far just to get to this point. So yeah. Anyway, that's the plan. Instead of just scrubbing this whole computer and starting fresh. Okay. Anyway, we're still running the up-down counter. I want to let that go for about an hour and make sure it doesn't glitch out, and then we'll be good to proceed. Thanks for watching.